Okay, so on 11.1a, I've split this up into two sections. It's simplifying radicals. Radicals is another way to say square root, or when you get into cubed roots and things like that. The radical is the little house-looking thing. So multiplication property of square roots looks like this. The square root of a times b is the same as the square root of a times the square root of b. So if you had the square root of 54, you could write that as the square root of 9 times the square root of 6. Okay? Now this AB does not stand for the 5 and 4. It means A times B. Like what two numbers multiply give us 54. Okay? You're looking for perfect squares. Okay? You want a perfect square in here because then you'll take the square root of it. So in your calculator, you might have to mess around for a little bit to try to find what perfect square goes into 54. Okay, so this would then become, well, the square root of 9 is 3, and then 6, you can't break 6 down anymore because it's just 3 times 2, which neither of those are perfect. So you would leave it as 3 times the square root of 6. Okay, you would just leave it like that. And we're going to do lots of examples here. Okay. Once I get some more things here. Okay. Okay, so our first example, the square root of 192. Okay, well, I'm not exactly sure what times what equals 192, so you might have to start by going through your perfect squares. Does 4 go into it? Does 16 go into it? Use your perfect squares. Does 25 go into it? I know that 64 goes into it, so 64 times the square root of 3. Okay, well then the square root of 64 is 8, and you're left with the square root of 3. So 8 times the square root of 3. You're just rewriting it. It's the same thing. If you put this in the calculator and 8 squared to 3 in the calculator, you get the same decimal out. Okay, so the square root of 50. Okay, well right away you might think 5 times 10. Well, 5 times 10 does not, neither of those are perfect squares. So then you'd have to do the square root of 25 times the square root of 2, which is 5 square roots of 2. Okay, these will just take some practice. Number 3, negative 5 square roots of 300. Okay, so this negative 5 will stay, and we're just going to multiply that by whatever we can figure out for the square root of 300. Okay, well, right away, we know that 100 is a perfect square, so we can do square root of 100 times the square root of 3. Okay, well, the square root of 100 is 10, and then we have the square root of 3. So this would become negative 50 square roots of 3. Notice how I kept that negative 5. I just kept it with me, okay? Square root of 18, okay? So you have to think to yourself 9 times 2, because 9 is a perfect square. Okay, if you were thinking 4 doesn't go into 18, so you wouldn't use that. Okay, now you can also write it like this, square root of 9 times 2 under there if you want. I don't like that as well, but you can. Okay, so then the square root of 9 is 3, and then you're left with the square root of 2. Okay. Okay, so now after you kind of get used to that, then we're going to throw in variables, which tends to be a little bit more confusing. Okay, so if we have the square root of 45a to the 5th, okay, so that means we can do 9 times the square root of 9 times the square root of 5 times. Now, you want to break them up into perfect squares, where the perfect square would be a squared times a squared times a, the square root of all those. So this, remember, when you multiply these together, this is going to give you a to the 5th. I just broke it up into perfect squares. Okay, you could technically have a to the 4th there, but I thought that might confuse some people. Okay, so this is going to become 3. This is going to be the square root of 5. This becomes a. Okay, because we've learned if you take the square root of something squared, it becomes a. This is also a, and this one you would leave as the square root of a. Okay, so all the things that don't have square roots go on the outside. So we're left with 3a squared square root of a on the inside. I'm sorry, square root of 5. Let me erase that. Square root of 5a on the inside. I missed that 5. Oh, where did my pen go? And it stopped working. Okay. Square root of 5. Okay. Why can I not get the right pen? Oh, because it's down here. The square root of 5a down there. Okay, because this 5 and that a are under the square root, or the radical. I should keep saying radical. Okay, under the radical. So if you take the square root of a to the 5th, a to the squared comes out and you're left with a in the inside, because you can only take the perfect squares out. Okay, we'll do some more. Okay, I don't remember what number we're on, 7. Okay, so the square root of 60a to the 7th. Okay, so we would do, you know, you might think 6 and 10 to get 60, but those aren't perfect squares. Okay, so you could do 4 times 15, square root of 15. Okay, and then we have a squared, that gives us 6. I mean, that gives us 4, this gives us 6, and then we're left with 1 to get a to the 7th. Okay, so we're left with 2, and then square roots of 15. These are all being multiplied. This gives us a, this one gives us a, this one gives us a, and this is still the square root of a. So all of the things that aren't under a radical go on the outside. So 2a cubed square root of 15a. Okay. Now, the second part of this one, oh, I think I skipped one in there. That's okay. I think I skipped number 6. Okay, so if we had, let's say we had negative a on the outside, and then we had square root, I'll just say 27a squared. Okay, so then you keep that negative a, and then the square root of 27 is square root of 3 times the square root of 9 times the square root of a squared. So when you come down here, you still have your negative a. Square root of 3 would stay that way. Square root of 9 is 3, and the square root of a squared is a. So on the outside, you're going to have negative a. Whoops. Let me put the 3 first. Hello. That's wrong. Why can't I find my pen? There we go. Negative 3a squared, because these two a's. Okay, you're multiplying them, remember. You're not adding them. You're multiplying them. And then under the radical would be the 3. Another 3 from right there. Okay. All right, next one. What if we had the square root of x squared y to the 5th? Okay, so basically multiples of 2 are going to come outside, but I'm still going to break it up. So we have x squared, we have y squared, we have y squared, and then we have y1, which would give me y to the 5th. So this would be x times y times the square root of y. Okay, so this would become xy squared on the outside, radical y. All right. Now, if you're given, let's say, negative 8 times negative 12, okay, then that becomes, you can multiply those together. So it becomes the square root of 96. Now you have to work backwards again because the 8 and the 12 were not perfect squares. And like before, you have to come up with perfect squares. So square root of 16 times the square root of 6. Okay, so this would become 4 times the square root of 6. Okay, so this one, it seems like you're having to kind of go back and forth, but that's just kind of what you have to do, unfortunately. Okay. Let's do, I'll just make one up. the square root of 5 times the square root of 10. Okay, well, neither of those are perfect squares. Okay, so you have to multiply them together to get the square root of 50. Then you break it up into perfect square. 25 and 2, and this would become 5 square roots of 2. All right, now if we throw a letter or variables in there, so if we had 2b, square root of 2b times the square root of 10b, again, neither of these are perfect squares, but when you multiply them together, it becomes 20b squared. Okay, well, 20 can be split up into the square root of 4 times the square root of 5 times the square root of b squared. Okay, so the square root of 4 becomes 2. The square root of 5 stays how it is. The square root of b squared is just b. So my final answer is going to be 2b square roots of 5. All right. Now if we add a little more, 3 square roots of 2b times 4 square roots of 10b. Okay, so this is important here. You multiply these outside together to get 12 square roots of 20b squared. All right, so this is going to give me 12 times the square root of 5 times the square root of 4 times the square root of b squared. So we have 12 square roots of 5 times 2 times b. So we'll have 24b square roots of 5. That's what your final answer would be there. Okay, now let me do one more and then that'll be it. Okay, I want to give you lots of examples to help because this is kind of new concepts here. 5 times 3c times the square root of 6c. Again, this is going to give us 5 square roots of 18c squared. Then we split our 18 up. We try to find a perfect square. So 9 and 2 and then c squared. So then this would become 5 times 3 times the square root of 2, or radical 2, times c. So 15c square roots of 2. All right, and we're done.